Have you ever experienced the thrill of sitting in a roller coaster or Ferris wheel? What is your experience? How do you feel at the topmost point of the circle and at the bottom point? Does the speed varies while ascending the circle and while descending the circle? What kind of motion it is called? Vertical circular motion. When an object revolves in a vertical circle around the center of the circle, the motion is called as vertical circular motion. For example, a mass tied to a string whirled in a vertical circle performs vertical circular motion. This type of motion is non-uniform and it is controlled by gravity. Let us try to understand the dynamics of vertical circular motion. In this model, you can observe an object which is attached to a rod and it is performing vertical circular motion in a circle of radius r. When the object is in vertical circular motion, it will cross different points. For our simplicity, we will consider different points like topmost point A of the vertical circle, the bottom point B of the vertical circle, point C and D which are horizontally placed, and intermediate point P. Let us try to analyze the forces acting at each point. The vertical circle is divided into 4 quadrants. Let us consider the topmost point of the vertical circle, that is point A. At point A, the tension in the rod acts in the downward direction, that is towards the center of the circle, and the gravitational force is also acting in the downward direction. Therefore, the minimum initial velocity that the object should have to complete the vertical motion can be calculated by balancing the forces. So, at the topmost point A, the rod is balanced by the centripetal force, which is mv square by r, minus the gravitational force, that is mg. When the object is revolving in a vertical circular motion, at that point, at the highest point, the tension in the rod is considered to be 0, and therefore mv square upon r is equal to mg, or we can have v is equal to square root of rg. So this is the minimum velocity at the highest point, which is required. The object has both kinetic energy and potential energy. So at point B, the tension in the rod is acting towards the center and the gravitational force is acting opposite to that in the downward direction. So Tb minus mg is equal to the centripetal force, that is nothing but mvb square upon r. Since the object is undergoing vertical circular motion, therefore the total vertical displacement will be equal to 2r. By using the conservation of energy, we can say that potential energy at point B must be equal to the change in kinetic energy at point B. Therefore, 2r into mg must be equal to 1/2 mvb square minus 1/2 mva square, or 2 mgr is equal to 1/2 m into bracket vb square minus va square. Cancelling m on both sides, we can write vb square minus va square is equal to 4gr, or Substituting VA as square root of GR, we can write VB square is equal to phi RG, or VB is equal to square root of phi RG. This is the velocity with which the object should travel so that it can perform the vertical circular motion. Now let us consider the object to be at position P. At point P, the forces acting on the object are the tension in the rod, which will be acting towards the center of the circle, the gravitational force mg, which will be acting in the downward direction, and this is divided into two components, one along the radial, that is mg cos theta, which will balance the tension, and the other component perpendicular to it, that is mg sin theta. If the initial velocity is smaller than root phi rg, then the object will not move in a vertical circle. The net force at point P in radial direction will be equal to T minus mg cos theta. Therefore, the net centripetal force Fc will be equal to T minus mg cos theta. But we know that the centripetal force Fc is equal to mv square by r. Therefore, tension T will be equal to mv square by r plus mg cos theta. According to the conservation of energy, the potential energy at point P must be equal to change in kinetic energy at point P. Therefore, mgr must be equal to kinetic energy at point P minus kinetic energy at point B, or 2mrg is equal to 1/2 mvp square minus 1/2 mva square. Therefore, 1/2 mvp square is equal to 2mrg, or vp square is equal to 4rg, or vp is equal to square root of 4rg. This is the velocity with which the object must travel at point P. Similarly, you can find out the velocities at point C and D. Try doing this on your own. So, at point C and D, the forces which are acting on the object are the tension in the rod that will be acting towards the center of the circle, and the gravitational force, that is mg, which will be exactly in the downward direction and at an angle of 90 degree with the direction of the tension in the rod. Similarly, you can write down the equation for this as the tension in the rod is given by mvc square by r or mvd square by r. Again, balance the energies at point C or D and try to calculate the velocity at point C or D. Also, have fun while whirling a bucket containing water without spilling the water. Tell me whether you could do it successfully or not. Thank you for watching.